Hi, so we're in section 4.3, and what we're going to learn here is we're just going to look at some different rules of probability. And in particular, we're going to work on the probability of A or B. We have two different situations here on the board. This is the whiteboard from the previous lecture, so from the previous video. So we have two situations. And the pair of events on the left are mutually exclusive. They have no outcomes in common. And the pair of events on the right are not mutually exclusive. They have one outcome in common. And just to catch up, event A is that you roll, the experiment is that you roll two dice, six-sided dice, and they're fair. And event A here is that the sum is 4, and event B is that the sum is 7, and there is no way to roll two dice and to get both the 4 and the 7. So the sum 4 and the sum 7, so these are mutually exclusive events. The fact that they are mutually exclusive is sort of part of what we see in the AND event, having a probability of 0. Looking at the pair of events on the other side of the board, event A is that the sum is 4, and event B is that the sum is, that a double shows. And we see that in this case, there is an event in common, 2 and 2. And so the events are not mutually exclusive. And in particular, we see that the probability of A and B is not 0. Okay. So what we want to consider is looking at the probability of A or B, and this is going to be called addition rules. Probability of A or B are the addition rules, and there are two different addition rules in this class. One of them is for situations where A and B are mutually exclusive. Then we're going to use the general addition, the special addition rule. So let me write that out. So the special addition rule and that's for the case when A and B are mutually exclusive. Then the special addition rule says that the probability of A or B is equal to the probability of A plus the probability of B. Okay, so what we have here then is, let's go ahead and calculate this. So using the special addition rule, we have the probability of A or B is the probability of A, 3 over 36, plus the probability of B, 6 over 36, which, adding them up, 9 over 36. That's the special addition rule. We can only use it for mutually exclusive events. And we're not going to, this isn't really a proof, but it is nice to note that when we calculated the probability of A or B, using the equally likely outcome method, which just counted up the outcomes in A or B and divided by the size of the sample space, we got 9 over 36. And now when we calculate the probability of A or B, using the special addition rule, we also get 9 over out of 36. Good. All right, so let's go to a more general situation where A and B are not mutually exclusive, okay? Actually, this is a general situation, so it would actually work in both situations, but we'll start with the general addition rule. Says that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, okay? And what I'm going to do is I'm going to go to our table here, and I'm going to find these probabilities and use them in the general addition rule. and see if we come up with the same value that for probability that we came up with when we were using the equally likely outcome way of calculating probabilities. All right, so probability of A is 3/36. Probability of B is 6/36. And the probability of C, we're going to subtract 1/36. So first, we'll just kind of add this up. We get 9 minus 1, it was 8/36. So the first thing I want to do is note that the two methods of calculation gave us the same answer. And then the other thing I want to talk about is why this formula works. So what we have when we calculate the probability of A is everything in the circle on the left. And what we have with probability of B is everything with the circle on the right. But notice that what we did when we did that is that the common event got calculated twice, included twice. So in order to not include the probability of 2, 2 twice, we had to subtract it once. Okay, so I like to think about if you had construction paper, right, and you were gonna make a big circle and then make another big circle. Really, the area of the circles of this sort of upside down 8 section has been counted twice. So you have to cut that out of the second guy, and really only you're looking for that, and then you're looking only for this other piece. So you don't want to count the probability of the overlap twice. Okay, so that's the general addition rule and the special addition rule. We're going to move over to the notes and see if there's anything else that we need to talk about. So sharing screen. Okay. So this is the special addition rule. It's for the situation when A and B are mutually exclusive. It extends for more than 2 events, 3 or more events. You just would add up. As long as they're mutually exclusive, the OR probability is the sum of the individual probabilities. I believe that is the problem that's on the board, and this is the other problem that's on the board. So let's talk a little bit about complementary events. An event A, let A be an event. And then the event not A is the event that is made up of all the outcomes in the space that are not A. So consider the experiment of rolling 1 die, and event A is a number bigger than 2 shows, and so here we have event A. So the probability of event A, there are 4 ways event A can occur. The size of the sample space is 6, so the probability of event A is 4 out of 6. If we look at the event not A, okay, it's everything that's not in A. It is the outcomes 1 and 2, and the probability of not A is 2 out of 6. So there's a rule where you can calculate the probability of the complement event. It's called the complementation rule. And that's for event A, the probability of not A, for any event A, the probability of not A is 1 minus the probability of A. So the probability that an event occurs is equal to 1 minus the probability that the event doesn't occur. Okay. So I'd like to ask you guys to also remember to check in with the formula card. I'm going to bring it up real quick and then share my screen once I have it, just to make sure you're following through with finding the formulas and working with the formulas. So where we are now, okay, so finding the formula card, that's on Blackboard. And just take a minute to look here. So these were the formulas from chapter 3. this formula here, we didn't go over. Maybe you'll use that if you're interested in it. If you like, from my math lab, my stat lab, they use that. I always sort of focus on what they're calling the defining formula. I like to stay with that because then the components of the calculation make sense, but they are equivalent and you can use either one. And so here we are in chapter 4. This is the equally likely outcome. This is the complementation rule, the general addition rule, and the special addition rule. So we'll be using these two in the videos for the next sections. All right. I'll see you in the next video.